Good morning. Good morning, everyone, and thank you for joining me today. My name is Gaurav Changwan, and I am a master degree student from the Kasesa University. I'm working with the Applied Research Network Lab. Today, I will be presenting about detecting botnet via DNS traffic analysis using machine learning. And I'm excited to share the technique and insight that I have been working for. Let's talk about growing up cyber threat. Cyber attacks are becoming more frequent and more advanced. Hackers keep finding the new way to break into the system, making an old defense less effective. We need a smarter and more adaptable security. These attacks can be lead to some financial loss from the downtime or recovery costs or as fine, but the biggest impact is company reputation. Once your trust is lost, it's hard to get back. With more sensitive data information online now, cyber criminals have a bigger target. A single data breach can expose a million of a record later, something like identity thief or some fraud. So a lot of attack now is something like DDoS or some ransomware can shut down the operation that costing the revenue and damaging your customer relationship. The graph on the left side represent the sharp rise of the botnet command and control today. This data from the last decade. You can see this not just increasing, they are accelerating. Let's breaking down to the botnet and why they are the major cybersecurity threat. So, what are the botnet? Botnet are the network of computer that botnet are the network of computer infected with malware and controlled by the hacker. This infected computer can be located anywhere. The owner often don't realize them that they are compromised. How do they work? At the core of the botnet is the command and control server. This server allows the attacker to control the bots and directing them to carry out the various tasks like launching an attack or stealing data or spreading spam. Also, botnet can often use for the DDoS attack where the bot flood the target server with traffic, making it inaccessible. They are also used as something like data thief and distributing malware, which can cause significant damage. The diagram on the left side shows how the botnet works. Once hackers give the command into the command and control and distribute it to the bot. Now let's dive into the botnet communication with the command and control server, which is the key that we have to understanding to how, which is the key that we should understanding and how to stop them. First is single IP address. This is the simplest method that botnet use. It's one IP address to communicate. It's easy to set, but also easy to block. Once the IP is flagged, security team can shut down it quickly. Next is a single domain. Instead of the single IP, the botnet use a domain name. This often make flexibility because the domain can point to different IP. However, once the domain is identified as a malware, it can easy to block too. Then is a dynamic domain. To avoid the detection, botnets start switching between the multiple domains. This makes it tougher to block them all. But because the domains are pre-registered, there are still some small patterns that security team can catch it. Finally is a domain generation algorithm. This is the most advanced method. DGA generates a random domain on the fly, making it extremely hard to detect. The botnet and CNC server use the same algorithm to connect it, making the communication much more harder to disrupt it. Let's talk about the domain generation algorithm. Domain generation algorithm is one of the trickiest methods that used to avoid detection and make the bot and CNC server stay connected. What makes a DGA so effective? Instead of sticking in one domain, DGA create new random domain constantly. This make it really hard for cybersecurity team to block them all. And how does it work? The botnet malware use DGA to generate a list of domain. Both of the bot and CNC server know each algorithm, so they can stay in sync by using the same domain to communicate. And why is a challenge? Because the domain name keeps changing and changing, even if some of them are blocked. The botnet can quickly switch to the new one and keep its operation run smoothly. The diagram on the right side shows the process of the DGA. Let's walk through about domain generation algorithm, how it works. It starts with user visiting malicious website there. Then the website secretly serving malware into the user device and turn it into the bot. Then when the bot want to communicate to the bot master, they need to generate the domain, but it need a seed first. The malware grab the seed, maybe something like a current time, or something like a number, or some predefined string that hacker that predefined into the bot. So then the attacker who already know the seed have to generate the same list of the domain and register one. Then the bot query this domain. Even when it hit some register ones, they can communicate together. Let's take a closer look at how machine learning is applied in cybersecurity, focusing on two key phases. One is a training phase, and second one is the protection phase. First, in the training phase, we gather the data include the both of safe and harmful example. The model learn to see the pattern and helping it tell the difference between normal behavior and threat. The more varied that of the data is, the better the model can get predicted. Now moving into the protection phase. After the training, the model is deployed to analyze the new data. It classifies this data as either benign or malicious. If threat is detected, the system can block it, or it can use it as alert into security teams. Let's explore why the random forest is a smart choice of DNS security. First is the high accuracy. Random forest excel at spotting threat by combining multiple decision trees, which helps to reduce error and reliability to identify threat in DNS traffic. This level of accuracy is essential for keeping your system secure. Next is complex data handling. DNS security involves managing a large and varied data set. Random forest handle this complexity by breaking into the data into the smaller part and processing them in parallel. That makes sure that nothing that important get missed. Then is resilient to overfitting. Overfitting can cause the model stuck in with new data. Random forest avoid this issue by averaging multiple decision trees, keeping the model reliable even the data is complex. This reliability is crucial for effectively cyber sex. Finally is the real-time analysis. Speed is the key. Random forests can quickly process and analyze data, making them perfect for real-time threat detection. This allows your system to respond almost instantly to potential threat, keeping your network safe. Before diving into the implementation detail, I would like to point out that I already published some of this work. The first one is published on the ECTIR. This is one of the journal in Thailand. The second one is it has been accepted for ICSec yet, but it's not been published yet. Let's explore how to implement the random forest in cyber defense. Breaking down into the 4 key stages. First is the data collection, second is the feature selection, and third is model training, and the last one is deployment and monitoring. First, data collection. Our journey starts by gathering data from the 2 crucial sources. This benign domain, we pick it from Alexa top 1 million domain, and malicious one, we pick it from the dataset that provide from this paper. By combining this, we create a dataset that teach our model to spot the difference between normal and malicious traffic. Moving to the feature selection. Picking the right feature is a key for effective detection. We focus on the 9 features which highlight on engram analysis. Through the testing, we discovered that FOCAM is provide the best performance in term of accuracy, precision, and accuracy, recall, and event score. You can see in this graph. This one. Here's how it FOCAM work. We start by removing the top level domain from the domain name. That, for example, we have the hackinthebox.org. We remove the .org from the domain name. And next, we apply the sliding window technique in this domain by moving a window of 4 characters by 1 character in a time, like this. First, capturing HACK. Then is ACKI. We continue this pattern until we reach end of the domain. So in this example domain, we have the 9 of the 4-gram character set. The formula on the slide is show how we figure out the probability of FOCAM. This analysis can help us identify this unusual pattern, make it easier to spot potential threat hidden in DNS traffic. Another important feature is character set probability. The metric look likelihood of a specific 4-character sequence appearing, which can be critical in detecting unusual or suspicious domain. The formula on the slide show how we figure out the probability. This report is different from the FOCAM. Instead of the focus of specific or pattern or sequence, we are looking for overall likelihood of this sequence appearing in any domain. If a sequence is very rare, it could be a red flag, hinting that the domain might be suspicious. Another essential feature is Shannon entropy, which is a measure of the randomness of the domain name domain. The formula is on the slideshow. That is how we figure out the entropy. The domain with the high entropy, like something like that, that's the first example, often look random and are likely generated by DGA. This type of the domain are more suspicious than the straightforward one, like the hackinthebox.org. So we can use it because high entropy is a key indicator that something might be off or signaling something like malicious activity. We also use order of key feature, something like a number of consonant, number of vowel, and domain range. In addition to the feature that we discussed above, we also took 3 of these following is ratio of consonant to length, ratio of vowel to domain length, and ratio of entropy to domain length. Together, these features empower our random forest model to efficiently detect and defend against cyber threat. Now that we have chosen our key feature, it's time to training model. We use Python and the scikit-learn library that known for the strong machine learning capability. Scikit-learn provides the tool that we need to train our random forest model and validate its performance. By using this tool, we can efficiently process the large dataset and teach our model to accurately detect threat. Now let's move to the deployment and monitoring phase, which is the key of the real-time threat protection. This is our architecture. We begin with a node resolver, which handle DNS query and integrated with DNS tab for logging every DNS message in the real time. This data is important for the spotting suspicious activity. The log are saved as a simple text file for easy to access. Then we use 5-bit forward this log into the data pipeline, connecting the raw data to our analytic tool. Next is logstash. Logstash step into process the data. It filter and format the raw log and preparing them for the deeper analysis. This structured data is stored in the Elasticsearch, which allows us to search and analyze the large of data set. Then our machine learning model that, like we talked in the last slide, we build with Python and scikit-learn. Then we write to put the data from Elasticsearch. Finally, we use Fast API and Vue.js to create a user-friendly interface. Fast API run as a backend, and we use Vue.js run in the front end to make a dashboard for real-time monitoring. This setup allows analysts to track DNS traffic and respond to threat immediately. For combining this together, these two make our system ready to monitor and defend against DNS-based threat in real time. In cybersecurity, accuracy in threat detection is very important, but we also need to think about the training time. When designing the model, we often have to choose between accuracy and speed. We need our model to be accurate, but if your training time is too long, our system might not keep up with new threats. Finding the right balance ensures our defense system stay both effective and quick to respond. The time it takes to train our model affects how often we can update them, and in the world where the threat change quickly, be able to update our model fast is really important. If training time too long, we might miss new type of attack. Fast training is allow model to quickly adjust to the new threat. At the first graph show the number of 3 affect training time. By choosing the right algorithm and setting, we can update our model more often and keep our defense strong. And fast training also helps to save some computing resource. The second graph shows how the time to calculate metric that slow down as the number of trees increase. By optimizing the training process, we can keep accuracy high while using our resource wisely. So in summary of this slide, why accuracy is the key, but the speed is important too. Next, let's start by looking how training time change with the number of 3 when we just using one core. The graph on the left is the same as last slide. The graph on the left show that we have when we have more tree, training time increase quickly. This expected because more tree mean more work for the computer. We slow down the training process in single core setup. This can make it hard to update model quickly, especially as we try to handle more data. Now, let's compare with using multicore. The graph on the bottom left of the screen show that what happened when we use a 32 core. The difference is clear. Training time is dropped significantly. Even the more tree multiple core allow the computer to work on several tasks at once. This faster training is important in cybersecurity, where being able to quickly update method can make the difference between stopping a threat in a time or missing it. Finally, let's look at the efficiency gain. Shown in the new graph on the left side, this is training time on the 1 core versus 32 core. As the number of the tree going up, we'll see the big improvement in efficiency, often over 20 times faster. This shows how the multi-core processing can help us keep our model bot accurate and fast, ensuring our detection systems stay effectively and timely. As we look ahead, there are some key challenges and future direction that's considered in our going fight against cyber threat. First is cyber threats are always changing. Attackers are constantly finding new ways to break through defense, so our system must be adaptable. This means we need to keep our model up to date and make sure we using the latest threat information in our detection strategy. Second is managing data is become more complex. With the growing amount of data, it's getting harder to process and analyze it effectively. Handling large data sets quickly and accurately is a key to detecting threat in time. This requires not only advanced storage solution but also efficient data processing system that can keep up with real-time demand. Finally, real-time processing is important. The faster we can detect and respond threat, the better we can minimize the impact. It is important to optimize our system for speed while losing as a little bit of accuracy as possible. This means use multi-core processing and constantly refining our algorithm to strike the best between speed and accuracy. Now here is three key takeaway from this presentation. First is balance is the key. Your model needs to be both accurate and fast to ensure strong cybersecurity. Second one is efficiency is called faster training time mean quickly update, which help you to stay ahead of the new threat. And lastly is using multi-core processing. It can significantly cut down the training time, making your system more agile and responsive. Keep these 3 points in mind when you build and refine your machining. Thank you for your attention, and I hope the insight that I shared today have provided you with a valuable perspective on improving cybersecurity through the effective machine learning strategy, particularly in the DNS traffic analysis. I would be happy to address any question you may have. Please feel free to ask.
All right. Thank you so much to our speaker, Korawit. Could we give him a warm round of applause and some encouragement? Well done. Any questions? Oh, wow.
I see you use the Enneagram model, right?
Yeah.
But how to prepare did you use any smoothing function because probability can be zero because some sequence we not found in datasets?
Yeah. Normally we use something like add a little bit of that constant to prevent the zero count. Something like you have the 1,000 of data set and you find that some of sequence is zero. We might add something like 0.0001 to make them not be zero.
Okay, then that means you smoothing function that you add a constant value.
Yeah.
Okay. Okay, thanks.
I think we had another gentleman wanting to ask a question. Yes.
Hi, I have two questions. The first one is about accuracy. Can you give us a result of percentage of true positive and false positive of your model? I believe that every model is not perfect, right? So, and the second question is about is your model able to detect the typo squatting? Typo squatting is a domain that an adversary deliberately register with a misspelled name. Thank you.
Our model didn't, for the typo squatting, our model isn't detected.
Okay.
We need to detect something like the randomness detection.
Okay.
Something that you might think is something like a hash. Do you know hash?
Yes.
The hash is the random string, right? Yeah. Mm-hmm. We detect something like that because some of malware use this technique to communicate it. Is the two case between the typo spotting and that one.
Okay.
Yeah.
And for the first question, the accuracy,
I didn't
true positive
prepare
and false
today.
positive.
Can you ask in the after of this presentation?
Okay, sure.
I prepared about the graph in this slide, but I didn't prepare it in the numbering. Yeah.
Okay. That's okay.
Sorry.
Don't worry. Thank you.
All right. So I was actually speaking to Korawitz. There's another question.
Another question. I don't quite catch the idea, but I may have misunderstand something. How often do you update your model? Because I see you try to reduce the training time, right?
Yeah.
But normally, I haven't seen. I think my training time is not much of an issue for most model because, like LLM, we can train is for like months, but I see you try to reduce it. So I wonder how often you update your model.
Firstly, I desire the daily update, but I'm cannot answer that. What should be how many days that you choose to renew the model? But when I design first, I design as 1 day can update daily. In the my in the 1 day I training the data, I use something like maybe for the 5 or 10 minutes is for the small data set. This graph is about I'm not sure the number is about 200,000 million of the data set. It's a small one that we use in about 90 seconds. We think that is too much for daily update. So we decided to minimize it. We use 30 core on the server, Dell server. I think it's too powerful instead of the something like normal usage. Yeah. So I
So the daily data is quite large enough to train
Yeah.
every day, like, right?
I think the data is quite large, but
About the data, if it's updated daily, have you considered the attack like data poisoning?
oh, that's quite interesting.
Data poisoning,
Yeah.
have you considered?
That is. Firstly, I didn't consider about that thing too much. Then thank you for the suggestion. We will take it and considering later.
I see.
Yeah.
I also have another question, though this time I'm not asking about the numbers, but in terms of like yes or no question. Has your model ever detected a legitimate domain, like and blocked it?
Sometimes it have we decide something like the whitelist tool, but
Okay.
we didn't show. Our model detects something like European university.
Okay.
Yeah, something from that. Then we have something like short name of the university name and make it our model is detected.
And what do you do after that? Like you blocked the legitimate domains, like you try to whitelist them.
Yeah,
off them
I
one by one
try
manually.
to whitelist them. Yeah,
Manually.
yeah, manually.
Okay.
Sometimes we have to, but sometimes in some domain that we cannot to block it in with early model, and we can whitelist it.
Yes,
early model
because I'm thinking of a way that I mean, like there are maybe hundreds of domains that can be blocked, right? And those domains might be legitimate. And I'm thinking of a way that you have to manually block it. Maybe it's quite a challenge as well, you know, because you have to like.
In minor real world deploy that we have a whitelist that we bring it for some of this from the top domain that have some public open source public source. We think that some of the top domain is a domain that's used in the real life.
Okay.
Something like when I use Alexa top 1 domain is duplicated. You have something like the umbrella that provide the domain. We test it that the 100,000 first domain is legitimate. So it helps us to fix something like that. It make it easier.
And what if like, let's say you have a 1 million domain and probably like 10% of it, 10% of those are legitimate domain that you blocked. What would you do?
Actually,
You can't like manually do it. But yeah, sorry, I'm spending too much time. Maybe.
no. Actually,
Maybe
thank you for your questions.
We can take it offline.
I wanted to
That's
interject
okay.
to say that it's your lucky day because other than Cora, we actually have the team who's supporting him right here sitting in front. Yeah. So I think it's definitely an interesting engagement. And how rare do you get the whole team, research team here, right? So
Yes.
I'll welcome you to speak at length with them. Later on.
Sure.
Okay.
Maybe we can.
And not just that,
target
I just
offline.
wanted to bring our attention to the fact that Cora here is actually presenting for the very first time on a public stage in English, and taking about 4 to 5 questions. I think he has done his best. So can we give him a round of applause to encourage him?